Hey, how are you guys doing? Hey, earlier today did a video on introducing what quadratic equations are and parabolas, finding the y-intercept, all that kind of stuff. And somebody asked if I would do a quick review of completing the square. So I thought, hey, yeah, it's a good idea. Let's just do that, completing the square. So what we're going to do is we're going to do a quick kind of overview. We're going to get into why we complete the square, what a perfect square is, kind of the shortcut, like the pattern that happens, what to do when a equals 1, what to do when a doesn't equal 1. But we're not going to get into all of the details like, the specifics about changing to vertex form or the specifics about solving using completing the square and then using inverse operations. We'll do that a little more carefully in the future. But for now, let's get to it, shall we? So here's the document camera. Here's the things we're going to do. Talk about why, what a perfect square is, the shortcut, what to do when a equals 1, and what to do when a doesn't equal 1. So first and foremost, the reason why we complete the square is, well, there's lots of reasons. If you're in an Algebra 2 class or an Algebra 1 class, you're probably not going to deal with circles or conic sections, but that comes up later. But for right now, the reason why you would complete the square, there's a couple reasons. Number one, they're easily factorable. And number two, they're easy to solve. If you have a perfect square, a quadratic, that's a perfect square, life's going to be good. It's going to be easy for you, right? So that's why we do it. Now, what a perfect square is, it's a number that's the product of another number squared. Like 25 is a perfect square. It's just a single number though. X squared plus 10x plus 25 is also a perfect square. See, 25 comes from 5 squared. This comes from x plus 5 squared. So if you were to take x plus 5 and multiply it times x plus 5, you would get this. And they are incredibly easy to factor because all you got to do is figure out what two numbers multiply to make 25 and then also add to make 10. So as factoring goes, it's really, 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 really easy. So let's take a look at a couple of examples of some perfect squares so we can see what this hotness right here is talking about, right? So we got like x squared minus 4x plus 4. That's a perfect square. X squared minus 12x plus 36. X squared plus 14x plus 49. So there's 3 right there. In all 3 of these, a equals just 1, right? But they still work out just fine. So check this out. This one right here, and this one, they all have a pattern that if you take half of b and you square it, you get c. What we're talking about is we've got standard form of a quadratic, ax squared plus bx plus c, right? So if you take half of b and you square it, if you take half of b, right, and then you square it, well, half of 4 is negative, half of negative 4 is negative 2 squared is 4. And that's what c equals, do you see? Whereas if you take half of b here, half of negative 12 is negative 6, and negative 6 squared is 36. Same here. Half of 14 is 7. 7 squared is 49. So that's the pattern. Every single time. We're talking about right now when a equals 1, every single time, half of b squared equals c. So you can leave me a comment down below as to what you think this one would be. So we're going to call this number 1. X squared plus, let's say 18x. What does c have to be? For number 2, how about x squared? We'll do. I don't know. I'll let you figure this one out. Plus 100. What does b have to be? So I'll let you do those 2 right here. If you're not sure, let me give you 2 examples. So x squared. Let's do x and then plus, how about, 64. And then we'll do another one right here, and I'll do this one right here. Right? So here's what I know. Half of this number squared has to equal 64. So what squared is 64 is 8. 8 half of 8 is half of what? It's 16. So I think this is going to be a plus 16. So if I took 16 and divided by 2 and squared it, would I get 64? That's really the question right here, right? So half of 16 is 8. 8 squared is 64. Oh, that works pretty good. If I couldn't figure that out like this way in my head, I guess if I had to write an equation, I could. I would say, well, b is the number we're looking for. I take half of it and square it, and the answer is 64. So you could use inverse operations to solve this. You could take square root of both sides. B over 2 equals 8. So multiply both sides by 2. B is equals 16. See? There you go. Whereas this one, all I got to do is take half of negative 8 and square it. So that would be negative 4 squared, which is 16. You see? So there's the shortcut. There's the pattern for these perfect squares. Half of b squared is going to equal c, and boom, you're done. No problems, right? All right, now let's talk about completing the square when a equals 1. So when a equals 1, we're going to talk about completing the square. And we're going to leave everything on one side. We're not going to be solving. So let's say we just had this expression right here. Let's say it was x squared plus 6x minus 7. So we want to rewrite that so that it is a perfect square. And the reason we want to do that is because it's then kind of easy to factor. This one's actually factorable anyway. This would be x plus 7 times x minus 1. But we're going to complete the square. So what we need to do is we need to take half of this number and square it, and that needs to be this. So if I take half of b and I square it, well, that's going to be 3 squared, which is going to be 9. I need this to be a 9. Right now it's not a 9. Right now it's a 7, right? Well, so here's one way you can go about it. You can kind of do it logically. You could, well, but it's kind of hard to explain that in a video. So let's just do it really, really patiently. So let's say what I'm going to do is I'm going to go ahead and rewrite it like this. And I'm going to leave a little space in there. You see what I did? And would you agree that what I have written right now, this and this, are exactly the same thing? They're not different at all. So if I take half of this and I square it and I add it, so half of 6 is 3, and I square it, and then I add it, and then over here, well, I would have to subtract it. So we've got a couple things going on right here. Check this out. First of all, this right here is half of 6, and I squared it because now this part, just this part alone, is a perfect square. You see? If I were to square this, I get 9, and if I subtract it from 9, well, that makes 0, and I'm left with the original. So everything I've done is okay. These two things right here are both completely equal to each other. This one just looks different. Now, what I did, took half of b, squared it, and added it, and subtracted it. Because they're both on the same side. There's not an equal sign. So this is still equal to what it was before. And so if I were to go ahead and now factor this, let's see, that's minus 16. Now here's what I did. Here's another thing. You noticed, I'm sure, here I did not square the number, but here I did. The reason I did that is because when you're completing the square, your next step after adding this right here is to go ahead and factor. And that number, with its sign, here it's positive, so I don't need to write a plus in there, but that number with its sign goes right there every single time when you factor, whether it's a fraction or anything like that, it doesn't even matter. Every single time it works like that. So we don't square it here, we do square it there. Here we factor, there we just combine like terms. So let's see one more example. Let's do an ugly one this time. Definitely not factorable. We want to change this into a perfect square, so we're going to complete the square. So our first step, we're going to go ahead and just rewrite it, leaving a little space, right? And we have to take half of this number and square it. Well, half of that number and square it. So we have to take half of that number and square it. We have to add it here, right? Negative 5 over 2. You see how I left the sign? See how I didn't square it? But over here, when I square it, I get 25 over 4. Now be careful. When I square this, it means times itself. So it's negative 5 over 2 times negative 5 over 2. And that is positive 25 over 4. I'm subtracting it though. So this one's going to be negative. This one's going to be positive. Now, we got to factor x minus 5 over 2 squared. Yeah? Here we have to combine like terms. Look, make this easy. This is a whole number. It's 1. So 1 is going to be the same as 4 over 4. And that's going to be negative 29 over 4. Make it easy. It doesn't need to be that difficult. Now here's the thing. A lot of the time, people aren't sure if this is actually right. This is right if I square this and combine like terms and I get that back. Let's find out, right? So x minus 5 over 2 times x minus 5 over 2, and then minus 29 fourths, right? Let's put all this together and see, because it doesn't look right. I mean, it seems like it's impossible, but all right. So you remember the shortcut, FOIL, right? First, outer, inner, last. So the first two make x squared. Perfect. Outside is negative 5 over 2x. Outside means like this, right? Inside, negative 5 over 2x. And the last two make 25 over 4. So let's go ahead and put all this together. So x squared, now negative 5 over 2 and negative 5 over 2, well, that's negative 10 over 2 plus 25 over 4 minus 29 over 4. I forgot to write the negative 29 over 4 on that one. Look at that, though. Negative 5 over 2 minus negative 5 over 2. Well, just minus 5 over 2. Isn't 10 over 2 the same as 5? So here's what we got. This right here, this is 5. All right, and these are the same denominator, so 25 minus 29, doesn't that equal negative 4 over 4? And isn't that equal to negative 1? Oh, here, hold on, let me move my paper. I'm sorry. I didn't know you couldn't see that. So look, here's what we got. This is x squared. It stays the same, no problem. This is going to be a minus 5x because 10 over 2 reduces. And 25 minus 29 is negative 4. Negative 4 divided by 4, minus 1. Same exact thing. We're good to go. So, completing the square. What you're going to do is you're going to rewrite it. You're going to leave space. You're going to take half of b, square it, and add it, and then subtract it at the end. You're going to factor the inside, combine like terms on the back end, on the last part. And you're done. That's it. No problems whatsoever. Easy peasy lemon squeezy. All right, now. Okay, I lied to you. I said I was going to get into something like, here, let me show you on the document camera, something like this today in this video, but we're already at like 12 and a half, 13 minutes, something like that. And that's pretty long. It's a lot of information already. So I think what we're going to do is we're going to save that for the next video. And what I'm going to do, I'm going to give you, say, 3 practice problems that you can try. And then if you want, you can leave your answers as a comment down below. If you're in my class, you can let me know through Google Classroom. So here's what I want you to do. I want you to complete the square for each of these. Okay? So number 1, let's do x squared plus 10x minus 3. For number 2, let's do x squared minus 8x minus 11. And for number 3 is going to be a tricky one. Let's do minus 7x minus 1. So try those 3 right there, and you can leave your answers or questions as comments down below, and I'd be very happy to hear from you. I'll get back to you, let you know how you did. And until next time, I hope you have a great day. Hope it helped. Let me know. Give me a thumbs up if you liked it. Love to hear from you. Leave me a comment, and I'll talk to you guys later.